Hi, my name is Shelbi Schimpf. I am a telescope operator for the submillimeter array. I was a helo-based operator for 5.5 years, at which point I transferred to our Cambridge, Massachusetts offices, and I've been the lead telescope second shift operator for the last 11. My talk today is the second part of observational planning. It's a continuation of Jeff Bauer's talk from earlier today. He talked about proposing for time. This talk will be about scripting your observation once you've gotten time. So let me share my screen. All right, so observational planning, part 2, the scripts strike back. So you did everything Jeff told you to do. You proposed for time, you were allocated time. Now what do? Now you need a script. One of the biggest takeaways from this talk should be you're not going to get your project observed if you don't have an observing script. So how do we do that? You use the script generator on the SMAOC to generate your script. This talk will walk through that process. And what we're going to do is talk about the mechanics of the script itself. There's going to be several other talks about the science between gain calibrators and the different theory of what you need to do for your science. But this talk itself is strictly about the mechanics of the script from an operations standpoint. But we'll give you some tips and hints on getting the most out of your script. So the general script format for the SMA, we use Perl scripts. And like I said, those are generated from the script generator. The normal format is an initial flux and bandpass calibration, followed by your science target loop, where you actually observe your science target, followed by a final flux and bandpass calibration. And within the script, we have other little parts of the script, including automatic pointing and transit calibrators, both of which we'll talk about in a little bit. So you come to the SMAOC, and this is the front page after you log in. Depending on the permissions you have for the site, will determine what this left menu bar looks like. But everyone will have these publicly available tools, and then you'll also have access to your projects. So if we click on My Projects, that will bring up all of the projects for which you are PI, COI, or an authorized user. Each project you're on will have its own code. The code is labeled depending on which semester you were allocated time. And each project will list how many tracks you were allocated. Some people are allocated 1 track per project. Some people get multiple tracks in a project, and all of that information will be here. So if we click on the project code, it brings you to this page. All right, this shows the source that you requested for that particular project, the frequency, the configuration, weather requirement, and then the status. So this project has not yet been observed. It's in the scheduling status, but as you can see, it needs a script. Again, biggest takeaway, you won't get out any observations for your project if you don't have a valid script. So if we click on the track overview and script, it'll bring us to this page. So again, all of the information auto-filled from your project, and you want to come to this button, create a new script using the script generator. So there will be different tools you'll need to use when you're creating your script. The SMA passband visualizer is one of them. There are going to be other talks at the school that discuss this in depth, so I will leave the detailed information about these tools to those other talks. But these tools can be found up in this menu, in the preparing to observe, in the proposing, preparing to observe. And most of you probably looked at these tools while you were proposing for your application for the school itself. So you've at least seen them in some sense, but there are other talks, like I said, that will give you more detailed information about these tools themselves. So once we click on the create a script using the script generator, it'll bring us to this page. Again, some of this information will be auto-filled from your proposal itself. Some of the other ones you'll have to fill in. So here you will fill in what tuning frequencies you want to use. With the exception of polarization, which would be the same frequency on both, and then they use the polarization. Polarization is a different type of script. You won't necessarily use this script generator for polarization scripts. But as other people have discussed, all of our observations are done dual frequency. Receiver A will be either the 230 gigahertz receiver or the 345, and receiver B will be the 240 gigahertz receiver or the 400 gigahertz receiver. So you can specify the tuning itself, what sideband, what chunk it's going to be centered in, and then any frequency offsets you need specified. Excuse me. Again, also, here's another link to the passband visualizer if you need it. Integration time will default to 30 seconds. The majority of SMA observing scripts use 30-second scans. Polarization tracks usually use shorter scans, as will some mosaicing scripts, but majority of the scripts will use 30-second scans. One thing to keep in mind with our correlator, with Swarm, it's continuously recording data. Every 30 seconds, we're getting a scan. Whether that scan is flagged good or bad, depends on the status of the array. If we're slewing between sources, if we're doing a TSIS measurement where we put the ambient load into the beam to calibrate the system temperature, those scans would be flagged bad. But every 30 seconds, a scan is being recorded. So, integration time, that's where you specify that. The number of target sources, my project was approved for 1, so I have 1 target source. The number of gain calibrators, you can specify here. Flux calibrators, passband calibrators, we'll talk about those a little bit more detailed in a couple slides, and then array configuration. Some of your advanced observing options down here. If you were allocated for a mosaicing project, the scheduler would recommend using the mosaicing tool to generate your script. That gives you, the number of offsets and gives them, does the pointings like that, rather than specifying, let's say you have a mosaic that you want to observe with 7 different pointings. The scheduler would recommend you use mosaicing target tool down here to specify the 7 different pointings rather than specifying them individually as separate target sources. One of the big gains from that is we do a TSIS measurement, a TSIS calibration between each of the target sources. So you're going to lose at least 1, possibly 2 scans each time you change your mosaic pointing. That type of scan or that type of TSIS measurement doesn't happen in the mosaicing format. So it saves you a little bit on the overhead there. Also, this observing loops. So if you were allocated time for 2 different sources that are separated in the sky, you can do your target loops using this. So if you have the observing loops are specified by LST. So if you have your first source that rises early, you can follow that. And once that sets, you move over to your second source. You can specify those observing loops by LST time automatically, rather than trying to figure out the other timings, manually in the script. So that's a big help if you do have different target sources or multiple target sources separated in the sky. And like I said, that's all done via LST ranges. Okay, if you click on the proceed on the bottom, you'll come to this page, and this is where you actually specify the names of the targets. So here we go. So I named it science target. I gave the RA and declination. The number of scans that I want on the source every time we go back to it is 30. I'm doing 30-second scans, so that'll be 15 minutes. And please note the hint, extra spaces at the start or the end of the target names can cause trouble, so make sure you don't do that. Here you'll specify your gain calibrator. In the tools section of that menu, it gives a list to the calibration, gives a link to the calibration list. You can sort that by RA and declination, so you find a gain calibrator close to your source. So you'll name which gain calibrators you want and the number of scans you want on each of those. And yeah, actually here, calibrator search, you can look for one that way too, okay? And right down here, this is, the bread and butter of your script. This is where you tell the script what you want it to do. You specify the observing script loop here. For this example project, it's pretty easy. It's a gain calibrator. Where's my mouse? The gain calibrator, 1 target, second gain calibrator, same target. It gets a little bit more complex if you have multiple science targets you want to do, And if you specified a different number of observing loops, you would have different links. You'd have 2 or 3, however many loops you specified, you'd have to do this for each one. But yeah, so this is where you specify what you want the script to actually do. Down here, the additional calibration outside the main loop. You can give flux calibrators. I had said I wanted 2, that's why I have 2 lines, 1 passband calibrator and the number of scans. For flux and bandpass calibrator, you can put objects that you think would be good calibrators for this here, but don't worry about it too much, because with RQ style observing, you may submit the script, but your script might not actually be observed for a couple of weeks or even a couple of months. So at that point, the flux calibrators that you specified might not be available on the particular night that we're observing your source. But one of the jobs of the scheduler is to go through the script that he's going to schedule that night, simulate it, and make sure all the calibrators are available. And then he also specifies the calibrators in such a way to optimize time on source. So on the night that we observe your source, if your source is rising early, we'll get on your source as soon as we can. Once it sets, we'll do the calibration at the end. If you have a source that's not rising until 9, 10, 11 o'clock Hawaii time, the schedule will front load the observation with all of the calibration at the beginning. So then once your source rises, we can get on it and then follow it over the course of the night and optimize the time on source. So you can specify examples of things you might want for this, but if you're not seeing anything at the time you create your script, you can put in a placeholder, something you think would be good or something you'd like to get, but it will be adjusted for the optimal observing once your track is actually scheduled. Down here we have a transit source. The upper elevation of the SMA, it defaults in the script to 83 degrees. So if you have a science target source that goes above 83 degrees, you'll need to specify a transit source or something for the script to observe while your source is above the elevation limit. You can do this to get extra passband calibration, things like that. And then, excuse me, pointing frequency. This is different now. So we used to have to specify how frequently you wanted to point, but now the SMA has automatic pointing within the observing scripts. So what we do is when the sun is down, they pick an automatic pointing target and point every 3 hours. If you're running your script when the sun is up, pointing is done every 30 to 40 minutes. That is automatically done in the subroutines of the script. It automatically picks a pointing source that is optimal for your script and the time it's pointing. So you don't have to worry about specifying pointing in your scripts anymore. All right, so one of the big things for your script is choosing gain calibrators. Mark Gerwell has already talked, I think he had an entire talk about choosing your gain calibrator and gain calibration. So I'm just going to hit the bullet points again here. Want something near the target source and bright enough to be detected. As he discussed in his talk, consider a second or even a third safe calibrator, something that is bright enough that you are familiar with. And how often you calibrate depends on the calibrator brightness and the configuration we're in. And when in doubt, calibrate more often. If you have multiple tracks for a project, if you run your first track and you realize, oh, I don't need nearly that much gain calibration, you can adjust that in your second track. But if you run a track and realize you don't have enough gain calibration, you can't go back and fix it. So when in doubt, calibrate more often, and then you can go from there. All right, so once we generated our script, we come up here and, whoops, I went back, sorry about that. So you get to here, and after we input all that information on the last screen we were on, it brings us here. So it tells us the target, RA and DEC, number of scans. We're doing 30-second integrations for this one. So your time on source in minutes. This gives you more information. It gives you what you put in for flux and bandpass. I didn't need a transit calibrator, so I didn't do it. And then this gives you the summary of the observing loop. So again, we specified calibrator source, calibrator source. So this would tell you what it should be doing and how long on each of those projects or each of those positions totally elapsed time for one loop. There you go. So if you're happy with everything that's here, if it's doing what you think it should do, you can do simulate observation. So when you simulate the observation, it will just default to the next available observing day. We normally start SMA observations at 4 UT, which is 6 p.m. Hawaii time. And so that just the next day at 4 UT is when this will default. That is perfectly fine if you're just generating your script, since again, in Q observations, you aren't exactly sure when your script will be observed. So simulate your observation, and then you can go through and it'll show the actual commands that will be sent to run your script. The output from the simulation is what we operators will see when we're running your script. So you can go through, make sure it looks like, it's observing your source. This is where you can check for typos and different things. Okay, so simulate your observation, and that brings you here. So up here is the script simulation results. If you are observing for, or if you are proposing for a source that doesn't rise for, till the end of the semester, you may have to go back and adjust the timing on the script simulator or the date to make sure this runs. But this is a good check to see if your script is doing what you think it should do. And then down here is the script itself. Okay, and then let's see. Yep, and then from there, whoops, I went too far, sorry about that. And then you get here, and this is back to that track overview page. And so now it shows, instead of saying there is no script, you have your script available to you here. Okay, you can manage your script directly if you wanted to go back and change a couple, like the number of scans on a calibrator or something. You can do that by managing the script directly. But you do have the script available, and your script will show up as available to be scheduled. In this part, the scheduling this track, if your track does get scheduled, the date on which it was scheduled will show up down here. Then it'll show the status, and then observations will show if it's been executed. So hints and tips for creating your observing script: get your script in early. In the tools on the SMAOC, we do have a schedule for the array configuration. When we change array configurations, especially those first few days, if people, people don't necessarily have their scripts in. So if you are one of them, we're just starting an extended configuration and you have time and extended, if you have your script in, it's more likely to be observed, especially in those first few days, because not everyone will get their scripts in right away at the beginning of a semester. When we have postdocs or pre-docs coming through the Cambridge office, I always tell them, put your script in right away, because if you are the only script that's in at the beginning of a configuration, your script is going to be the one that gets observed. So you might get better weather than you were expecting. If you have a lower ranked track, you may get, your script observed earlier than the ranking would suggest because you had your script in. So always get your script in early. Okay. Gain calibrators, again, we've talked about this a few times. Pick things close to your source that can be detected, and then you can check the other talks as well for more details on the actual picking and the needing of the calibration. Flux and bandpass calibrators, again, the scheduler will adjust those as necessary to optimize observing when your track is actually scheduled. Simulate your script. We have very good operators at the SMA, and we will do everything we can to make sure your script does what it's supposed to do. However, we don't know what you planned on it doing. So if you simulate your script, make sure it's doing what you want it to do, and we'll make sure it gets executed properly. And in that same vein, as I'm sure Jeff said in his talk as well, make sure you proofread. Proofreading for your proposals is important, as is proofreading your scripts. We have had people who, forget to put the number of scans for a gain calibrator, and they don't notice it early enough, and then their gain calibrator doesn't actually get observed. We've had people put extra spaces before a source, and then it doesn't actually observe that target source. Double check your coordinates. I've personally observed tracks where people have put in the wrong coordinates, even, just a typo in the coordinates. It was enough of a change in the position that it took the observation off and they missed a detection. So just make sure you proofread your script and proofread what you want it to do. questions about the scripts and the script generator can be sent to Glenn, and the operators are happy to help, with different things with the scripts as well. But if you do have questions about the script generator, you can direct those to Glenn Pettipaw at the email here, or your internal collaborator at the CFA, Asia A, or at the IFA. All right. All right, so stop share. So that's what we have for scripting your observations. Thank you for your time. Enjoy the rest of the SMA school and let us know if you have any questions. Thank you.